Alright, we're picking up on example 2 from 4.4. Maximizing the area enclosed by a fence. A farmer has 1,600 yards of fence to enclose a rectangular field. What are the dimensions of the rectangle that encloses the most area? So here we go. We have our diagram. It's a farmer who has crops. There's a fence around the crops. We want to know how much can he enclose. This is actually a big reason why quadratics ever came to be, where the Egyptians, not everyone has perfect square lands, so they kind of discovered quadratics to tax people. It's very, very interesting. If you're curious about it, let me know, and I can email you a link to that part of a documentary about math. Anyways, so that word that you see, most, that is a synonym for maximum, the biggest, which is just means vertex. And remember, with the vertex, there's always an x and y point. But instead of x and y in this case, the variables we're going to be working with are x and w. That's just because of the variables that they give us to work with. No other reason. All right. That's all we have, and then we have that the enclose. We have 1,600 yards of fence to enclose a rectangular field. Enclose, that means around. Around, when we have a shape, means perimeter. We know perimeter of this rectangle. Perimeter is 2x plus 2w. But we actually have the perimeter, how much space we get to enclose around. We have 1,600 yards of perimeter. So you have 1,600 equals 2x plus 2w. So that's our perimeter. And we actually have one more formula. You may or may not be able to see it. Area. We know area. Area is base times height, but in this context, it is x times w. So with just information we already know about rectangles and shapes and stuff like that, we were able to come up with two formulas. Now, anytime we have two formulas, we're usually going to substitute one into the other. But since it's asking us to find the vertex of this area, which means the most of something, the highest it could ever be, we need to get a quadratic out of this. So since we need to get a quadratic out of this, we need to plug some stuff into one another. So our goal is to find the most area. So we're going to plug something into the area formula. What we're going to plug in, well, we have other variables. Let's go ahead and try and solve for a variable with the perimeter. So I'm going to solve for w. It doesn't matter what you solve for. You can solve for x. It's up to you. So I'm going to solve for w. I'm going to solve for w by subtracting 2x to both sides. So we're left with 1,600 minus 2x equals 2w. And then I'm going to divide everything by 2. And when we divide everything by 2, we're left with 800 minus x equals w. So that's what w is. Now the reason why we need to do that is because we're going to substitute this in as w. We do this to form a quadratic. Remember up here in the first example, we plugged in the demand equation into the economics revenue equation to get a quadratic. We're doing the same thing here. When we have two equations, we can plug one into the other if they have similar variables in order to form a quadratic. So this is stating 800 minus x is w. We're going to substitute it in for w. So we have a equals x times w, which is 800 minus x. And from here, let's just simplify. To simplify, we have a equals 800x minus x squared. But let's rewrite that. So a equals negative x squared plus 800x. And remember that this is the a and that's the b. A is going to be -1. All right, now that we have a quadratic, we can go ahead and find the most, aka vertex, of the area. So to find vertex, we use our handy dandy formula of x equals -b over 2a. So we have -b, which is 800, over 2 times a, which is -1. So -800 over -2, we get 400. Now, does it say a specific, like, find this of the vertex? Like in this equation or this example right here, it asks for specifics. Like in part C, it asked us for the unit price, so we only found the x of the vertex. It's not asking any of that here, so let's plug this in. We're going to plug it into the quadratic. The reason why we plug it only into the quadratic is because quadratics is the only thing that can give us a vertex. So let's plug it in. We have area equals -x, which is 400, squared, plus 800 times x, which is 400. Now you can plug that all into your calculator exactly. My bad, I forgot that's minus. Why'd I put plus there? No, that's plus, you're right. Never mind, don't pay attention to me. I'm right. Um, you can plug this all into your calculator as is, and you'll get exactly the right answer. Your calculator can take all of this, but make sure it's plugged in exactly the way it looks. Okay, so we have two solutions. We have x is 400 and a is 160,000 yards. Now what the heck does this mean? So the largest rectangle that can be enclosed by 1,600 yards of fence has an area of 160,000 yards squared. Its dimensions are 400 yards by blank yards. So it said that x, right here, x is 400. So if that's 400 and we only have a perimeter of 1,600, doesn't that have to make all of them 400? Now bear with me. So if that's 400 and that's 400 and that's 400, if we add them all up, don't we get 1,600 yards? So that's how you would do it. You would fill out the x's as 400 or plug it back into your perimeter formula, this one right here. You can plug it back into this one. So you would plug x in and figure out the rest. So it's 400 by 400 yards, and that is our solution. All right, example 3. A projectile is fired from a cliff of 500 feet, or a cliff 500 feet above the water at an incline of 45 degrees to the horizontal with a muzzle velocity of 400 feet per second. From physics, the height h of the projectile above the water can be modeled by h of x equals -32x squared over 400 squared plus x plus 500, where x is the horizontal distance of the projectile from the base of the cliff. I did not put an image here because we're going to draw it out together. We're going to find the maximum height of the projectile. At what horizontal distance from the face of the cliff will the projectile strike the water? And when the height of the projectile is 100 feet above the water, how far is it from the cliff? So A lot of this is BS. We don't need any of that. You only start to care when they say, this is this, this is this, here's a formula, here's an equation, x means this, y means this. That's all we care about. So it tells us height is h, and x is horizontal distance, and it gives us our equation. So we're going to draw the image first. Forget about the equation. Let's draw the image. And I'm going to draw it to the right. So this is a real world problem. The real world happens in quadrant 1 because it's positive. It says x is the horizontal distance. That means that's horizontal distance. And h is the height. Height is up and down. That's how tall you are. It's how up and down you are. This is how it always is. Height is always y. X is always horizontal distance. So height is up and down. Horizontal distance is left and right. So if we're trying to find the maximum height of the projectile, remember maximum, that means vertex. And vertex, my bad, wrong color. Vertex always implies an x and y. But in this case, it's not x and y, it's x and h. So if we're trying to find the maximum height, we're looking for the h of the vertex. Before we start plugging stuff into formulas, let's look at this equation. H of x, that's the same thing as y, and y in this case means h, so we're just going to switch this to h equals negative 32x squared over 400 squared plus x plus 500. There is a lot going on here. Let's simplify. So we have negative 32x squared over 160,000 plus x plus 500. We can simplify this fraction by dividing by 32. They have 32 in common. And when we do, what we're left with is negative x squared over 5,000 plus x plus 500. Now trust me, that is a lot easier to work with than 160,000. So always try and simplify as much as you can before you plug stuff into formulas. Now we have to plug this into a formula. If you have a calculator, you can plug this into your calculator. Alpha y equals it. So alpha y equals, and then make sure you get it the way it looks exactly. If you don't have a calculator or you're unsure, come see me before or after class on Wednesday and approach me with this example, and I'll show you exactly how to plug it into your calculator. But I'm also going to show you how to do it by hand. So because it's asking for the h, which is the y in the vertex, we need to find x and then plug it in and get the y. So let's do that. We have x equals negative b over 2a. So negative b, which is 1, over 2 times a. A is negative 1 over 5,000. There's always a 1 in front of that x. Let's simplify here. We have negative 1 over negative 2 over 5,000. We just multiply straight across on the bottom. We can simplify our fraction because we can take a 2 out of each. They're both even, so we can take a 2 out of each. We have negative 1 over negative 1 over 2,500. Now, I say that let's make this look pretty because we hate the way this looks. So we're going to take this and make it look how we're used to seeing it, which is negative 1 divided by negative 1 over 2,500. Remember that this division symbol is the same thing as the line. So we keep, change, flip. You keep the first one, change the sign in the middle, flip the second one. So we have negative times negative, it turns to positive. So 1 times 2,500 is 2,500. That's what the horizontal distance is for x. So what that means is the maximum distance it will travel at the highest point will be 2,500 feet. Now let's plug this x back in to the simplified equation. So we have h equals negative x squared, and our x is 2,500 over 5,000 plus x, which is 2,500, plus 500. Let's do the easiest first. Combine these two. So we have negative 2,500 squared over 5,000 plus 3,000. Now I want you to plug this into your calculator exactly the way it looks. Alpha y equals, enter, so you can get that fraction bar, and when you plug it in, now this is where you're going to need to start learning how to use your calculator. You definitely don't want to do this by hand. It is horrible to do this by hand. So we plug it into your calculator and we get 1750. So the max height is 1,750 feet. So that means when you fire this rocket off the cliff, or this projectile, it's going to hit 1,700 feet at the max and then start to go down. Alrighty, part B. At what horizontal distance from the face of the cliff will the projectile strike the water? So horizontal distance, that means x. So at what x from the face of the cliff will the projectile strike the water? Nothing in here says maximum or minimum or any synonym of those words, so we're not talking about the vertex. What we're talking about, let's draw it out. So part B. So part B, it states we have a cliff. Then it states that we fire something off of the cliff into the water. So this is our height, and this is our horizontal distance, which is x. So what we're looking for is this distance right here when the projectile strikes the water. So we're looking for how far did it travel off the cliff before it hit the water. So what height when you hit the water is it? Well, think of it. If you're at sea level, you're at 0 feet. Water, ground, floor, all of that means height at 0. Alright, so let's make that h0 in our equation right here. We're going to make h0. So we have 0 equals negative x squared over 5,000 plus x plus 500. So now that we have no h and that equals 0, we can go ahead and get rid of this fraction. So let's get rid of this fraction by multiplying everything by 5,000. So we have 5,000 times 0 is 0. 5,000 times this fraction, the fraction just goes away. 5,000 times x is 5,000x. And 5,000 times 500, it's a pretty big number. It's 2,500,000. Now, I don't know about you, but I would rather work with big numbers than crazy fractions like this. So we're going to work with crazy fractions like this. Now, this is unfactorable. And who the heck who wants to try and factor this? Absolutely not. I love factoring. But I don't want to try and factor this. So anytime you need to solve for x, when it's a quadratic, so squared, and you're solving for x, you always just bust out the quadratic formula. The quadratic formula is x equals, that's what we're trying to solve for, so that's why we use it, negative b plus or minus the square root of b squared minus 2ab all over 2a. And where do the a, b, and c come from? Very easy, they come from our quadratic, a, b, and c. So let's plug it in. We have negative b, which is 5,000, plus or minus, sorry, the square root of b squared, so 5,000 squared, minus 2 times a, which is negative 1, times c, which is 200 or 2,500,000. Not often you work with those big numbers. All over 2 times a, which is negative 1. So we're going to simplify inside the radical. Don't forget your PEMDAS. So negative 5,000 plus or minus, we have 5,000 squared. 5,000 squared is 25 million. Times negative 2, so, minus 2 times negative 1, so that's positive 2. And positive 2 times 2.5 million is 10 million. All over 2 times negative 1, which is negative 2. We're going to simplify inside the radical some more. So negative 5,000 plus or minus 25 million plus 10 million, which is 35 million. All over negative 2. So since this is a word problem and it did not say to use exact answers, because it would tell you to use exact answers, since it did not tell you to use exact answers, plug that into your calculator, 35 million, and let's start working with the approximates. We're allowed to do that because we're looking for the closest, like best case scenario, like what's the closest answer we can get to. If it wanted exact, it would ask for exact. So we plug in the square root of 35 million, and when we do, we get 5,916.08 over negative 2. We're going to split this into two equations. We have negative 5,000 plus 5,916.08 over negative 2, and we have negative 5,000 minus 5,916.08 over negative 2. Because we have a plus and a minus in the middle, we need to separate them into two. So when you do the first one, you get negative 458, about there. I'm not going to the decimal, I'm just going to the closest answer, the closest whole number. And when we plug in the second one, we get 5,458. Now, we're looking for horizontal distance, that's x. Can you travel a negative horizontal distance? You can't. You can walk backwards, but you're not walking negative, you're just walking backwards. So your answers for applications with distance must be positive. So our answer is 5,458. Now what that means is the projectile traveled 5,458 feet before striking the water. It flew almost a mile off the cliff before it struck the water. It's pretty crazy. Alrighty. Part C. When the height of the projectile is 100 feet above the water, how far is it from the cliff? So it's saying h is 100. How far is it from the cliff? The cliff, how far from something is the cliff, is always your x. So for part C, bringing it all the way down here, it gives us h is 100, and we're looking for x, which is how far is it from the cliff. So we have 100 equals negative x squared over 5,000. Sorry about that, I had to pause for a moment. Alright, so we're still plugging in h as 100. So we have 100 equals negative x squared over 500 or 5,000 plus x plus 500. From there, we have to solve for x because it's asking when is this happening? When is always going to be x? Anytime you have that quadratic, a squared, you want to equal the equation to 0. The reason why we do it is because that is the best way to approach a quadratic. It sets us up to use the quadratic formula or to factor, which is pretty much the only way that we're going to be able to solve this. So again, I'm not going to want to try and factor this at all. I'm going to get rid of that fraction and use the quadratic formula. A lot of higher level math is just using the quadratic formula instead of factoring when you come to a quadratic. So we have 5,000 times 0 is 0 equals 5,000 times the fraction. What happens is the denominator goes away. 5,000 times x is 5,000x. And 5,000 times 400, we get 2 million. Okie dokie. So now let's use our quadratic formula. We have our a, our b, and our c. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So let's plug it in. We have negative b, which is 500, or excuse me, 5,000, plus or minus b squared, which is 5,000 squared, minus 4 times a, which is negative 1, times c, which is 2 million. And that's all over 2a, which is negative 1. Alright, let's simplify this. So we have negative 5,000 plus or minus 5,000 squared, which is 25 million. Negative 4 times negative 1 is positive 4, and positive 4 times 2 million is 8 million. All over negative 2. We're going to simplify inside that radical. So negative 5,000 plus or minus the square root of 33 million. All over negative 2. And since we're working with an application and it didn't say to us we need exact solutions or anything like that, we're going to plug 33 million into the calculator and take that square root. So when we square root 33 million, we're left with negative 5,000 plus or minus 5,744.56 over negative 2. And since we have that plus and minus in between, we need to separate our equations. We'll have x equals negative 5,000 plus 5,744.56 over negative 2. And we have x equals negative 5,000 minus 5,744.56 over negative 2. So when we plug our first one into the calculator, we get negative 372.28. When we plug our second one into the calculator, we get 5,372.28. So remember, because it's distance, distance can never be negative. Our solution is 5,700. The projectile will travel 5,772 feet before striking the water. On your homework, that little blue text below the answer box will tell you how to round. So make sure you're reading how it wants you to round. Um, so since there is no test, it's going to be your My Math Lab little assignment thingy for that. So make sure you get it done. Pay attention to your due dates.